Okay, so today's class will talk about relative motion of rigid bodies. Something similar was done in particles where we talked about velocity of one point with respect to another. So this is the analogous part in the rigid body world. So consider a rigid body. Let's attach points A and B to different points of the rigid body, and let me draw vectors from the origin all the way to A and B. So this position here is the vector RA and the vector RB. So what we are interested here is the motion of B with respect to A, or A with respect to B. So let me just randomly draw an arrow from A to B. Okay, so what we have learned in chapter 12 on particles was that we can write RB as the sum of RA plus the vector B with respect to A. Okay, this is just a vector sum when you have vectors. Basically, if you want to reach B, you can do it via A, or you could directly go from the origin. So clearly, if you have this, then if you take the derivative with respect to time, so differentiate with respect to time would give me d RB dt equals d RA dt plus d dt of RB with respect to A. Which is nothing but the velocity of B equals velocity of A plus velocity of B with respect to A. So the way you can think about that particular formula is through this graphical interpretation. The graphical interpretation for the above formula is as follows. So this is AB, the rigid body. It starts off like this, initial. Okay, now this is basically moving with time. That's why you have a velocity VB, VA. Let's say that ends up in a final position like so. Okay, you can think of the motion from the original, the initial position to final position as being decomposed into two parts. One part is you basically translate, so you move the body A, B parallel to itself, so that's translation. To end up in this position, you need to also rotate the rigid body about point A, so this is rotation. So if you want to find the velocity of B, it is basically velocity of A, which is the translational motion, plus the rotary motion, which is VB with respect to A.
Sir, if it's written as VAB, is
Yeah.
that the same value or is it different?
AB, it is the same magnitude but different direction. When I write B with respect to A, the vector goes from A to B this way. If I write A with respect to B, the vector will go that way. So it's just going to be negative of that one. So there is a derivation in the book, and I will not go through it, but you can actually write this, the second part, the rotation part, as omega AB cross with RB with respect to A. And you got to check the text for the derivation. Okay, in other words, velocity of B is velocity of A plus omega AB, or the angular velocity of AB crossed with the vector, position vector from A to B. It's the, if you are rotating the rigid body at angular speed, that's called the whole rigid body. It's the whole rigid body, or in other words, omega AB is theta dot, where theta is this angle. Let me call it theta dot, theta AB. That's what it is. So I just wrote the magnitude there, but it's we are only looking at planar motion, which means that omega AB is right angle, right? So it's turning this way, so the term gives you the direction of the angular velocity. Okay, so when we solve problems, we'll see that we'll be either given velocity of point A and the angular velocity AB, and we'll be told to find VB, or we might be given VB and told to find omega AB. Actually, it turns out that you'll be given, most of the times there'll be two unknowns in this problem. So that will be more clear when I do the problem. So there are two ways of solving problems, and you can choose either of those methods to solve the problem. We'll show you both ways. We'll do one problem both ways, and then I'll just stick to one method. So what of problems you can expect is, given the velocity of point A, find the velocity of point B, or given the angular velocity, well, given the velocity of angular velocity and velocity of another point, find the velocity of the other point. So what we do is we use solving word problems. So method one is use vector equation. So vector equations, which is basically the formula VB is VA plus omega cross so write as a vector and then compare I and j components. So what I mean by that is velocity of B is a vector in 2 dimensions, so it has an I component and j component. Similarly, PA has 2 components. When you take the cross product, you have 2 components. So on the left side, you have something which has I and j. On the right side, you have an I and j. So you look at for this equation to be valid, the I component to the left side should be equal to the I component to the right side, and the j component to the left side should be equal to the j component to the right side. And you can use that fact to solve for unknowns. Okay. What you see here is not one equation but 2 equations, because it's a vector equation. Okay. If you thought that was confusing, when I do the problems, it will be more clear. The second way to solve this is to use scalar equations. Okay. So this is again, look at the same equation. But then look at the x component of this equation. X component. So I might write this as x, x, x. What that means is I'm finding the velocity, but in the x direction. The velocity of B in the x direction, velocity of A in the x direction, and that in the x direction. So similarly, I can find VB in the y direction, VA in the y direction, plus omega cross RB with respect to A in the y. So that's the y component. So probably the analogous thing you've seen before is statics, right? When you wanted to find unknowns, what you did was you took forces and you resolved them in the x direction and the y direction, and then you said sum of force in the x direction should be 0, sum of force in the y direction is 0. This formula, which you see here, is similar to that. What you do is you find everything on the right side in the x direction, everything on the left side in the x direction, equate the things. Similarly, you do the same thing for y. Okay? It will be clear when I do the problem, but that is for people who are not comfortable with vectors, that might be a better way to do this. So the only thing you want to know is, well, this is kind of trivial how to figure this out, but maybe this is not trivial how to get the direction of that particular vector. Yeah.
I cross A,
Mm-hmm.
I cross A, coming from I did the sign.
Yeah, I can talk about that. I cross k is minus j, not j. But I'll show you how to do that. And there's an easy way to do it. There are 2 ways. One is to set up the determinant, and the other way is to something which I normally do, which is I think is much simpler, but it's up to you to choose. So I'm going to just show you how to find the direction, and then we'll solve problems, and hopefully that will make it more clear how to use these formulas. So this is AB, the same line connecting A and B, which I drawn earlier. I'm going to draw the vector. Okay, question. The vector I've shown here, is it B with respect to A or A with respect to B? I call it B with respect to A because the vector, because remember when we do origin and you have a vector this way, we try to say that's A with respect to origin, right? Similarly, when the vector points to B, you should say B with respect to A. So that's how I say it, and I think that's how people normally say it. So would you write this as B with respect to A or A? Well, this is B with respect to A, this is A with respect to B. Okay, so you'll write it clearly like the first one. So you can see that this one you will normally write as RA, right? You normally do not write RA with respect to 0 because 0 is for the origin, so you write it this way. So you can see if you forget, if it's A with respect to B, B with respect to A, draw a figure like this with the origin, you always write it as RA, right? So wherever the one vector points to is always the first thing over here, and fifth is is always A. So you can remember it from that. Okay, so I'm going to tell you how to find the VB with respect to A. Okay, VB with respect to A is omega AB cross RB with respect to A. Okay, so omega is always in the K direction, right? Which means that it points outside, right? Let me draw that here. So if you want to find velocity of v with respect to A, you need to take the cross product of a vector which points outside the plane and the vector which goes from A to B. So if you think of this vector, my friend here is the vector omega AB, and the reason why it's omega AB, if you curl the right hand, then you have term which is the direction of AB, right? So you want to find the cross product of K plus this direction crossed with this vector. So you need to go from here to here. Right hand rule. So to find the cross product, you go from, you curl your fingers from K to this vector. So you curl your fingers from this vector to A with respect to B. So the term gives you the direction of velocity of A with B with respect to A. So it turns out that this is always, and is always true for planar motion, velocity of B with respect to A always comes out to be 90 degrees to the vector AB. The other way, the simpler way, if you think this was very hard, what I like to do is, you take this vector, it's pointing this way, and you just turn it by 90 degrees in the direction of omega AB. So omega AB is going that way, so you turn it this way. That is the direction. So if you like, you can take the cross product like I showed you, or you could just take this vector A and then turn it by 90 degrees in the direction of AB. So if the vector pointed that way, or if this arrow was this way, then you would turn the vector this way. So the velocity of AB would be that way if the rigid body was turning clockwise. So that's an easy way to remember. So two things I want you to remember. What is the vector V with respect to A? You can think of this figure when you in order to remember it. In order to find the direction of velocity of V with respect to A, take the vector position vector from A to B, A to B, and turn it in the direction of triangular speed. That is turning counterclockwise. Okay, so that's the review. I'm going to start solving problems, and we'll do both those methods, and hopefully that will make it more clear and answer your question about how to take the cross product I and J. Okay, so if the roller A moves to the right with a constant angular velocity VA, let's call that VA. Well, it is VA, okay. So they already shown it. Determine the angular velocity of the link, which is this. Let's call that AB, and it's an unknown. And look, that I've assumed the direction to be counterclockwise. That's okay. You could assume it to be clockwise or counterclockwise, up to you. When you solve the problem, the sign will come out in the right way. So it'll take when you solve it, it'll tell you if it's negative or positive. So you could choose either way. I always choose things counterclockwise because counterclockwise is positive. And then you got to find the velocity of roller B at this instant. Okay, so it's up to you. If you want to choose upwards positive, go for it. So in this case, I always like to choose an origin right over here. J is positive upwards, and you got to find the velocity of B. And just to make it much easier, so we know that when A moves to the right, B will actually move down, right? We know that. But what I recommend is always take the positive direction to be based on your sign convention. The sign convention says positive J is upwards. So I'm going to take velocity of b, the vector is the magnitude b times j. Okay, so I've assumed that velocity of b is upwards, and what I'm claiming is when I do the math, it will come out to be negative, and that's how I'll know it's going in the opposite direction of the direction I assume. So velocity of a is given, it's 3, and we see that it's in the I direction, so 3I, and omega AB, the vector is, I'm going to call that omega AB, the scalar, times k. Okay, because omega AB is pointing in the direction outside the plane of the paper, that's k direction. So given that, let's use the vector method. So the vector method says velocity of b is velocity of a plus omega AB crossed with r b with respect to a. So all I have to do now is plug in velocities as vectors and then compare both sides. So I'll have an I and j on the left side, I and j on the right side. So VB is VBJ equals velocity of A is 3I plus omega AB, vector is omega AB scalar times k crossed with the vector from A to B. Okay, R B with respect to A is the vector which goes from A to B. So it's pointing that way. And that vector is at 30 degrees to the x-axis. So R I need to find the vector which goes this way. Okay, so the vector is given by the magnitude times the direction. The magnitude is 1.5 meters, the length of AB. So 1.5 is the magnitude, and to get the direction, okay, you see that the arrow from A to B is in this direction, right? So when you resolve it along the x-axis, angle is given to you 30 degrees here. I'm just showing that with respect to IJ, so it's easier to see which direction it's going. So I took AB and I moved it parallel that it's along, it passes to the origin, just so that I can find the direction. So the direction is going to be, if I resolve this vector in the x direction, it's going to be cosine of 30, but that arrow is pointing in the negative I direction, so it's minus cosine 30. Okay, and then to find the j component, it's going to be sine of 30, but sine of to resolve it points upwards, and upward direction is positive. So plus sine 30 degrees j. Is that clear? This is very crucial, you get the direction right, because your answers will not have the right sign if you do not get the directions figured out properly. I didn't quite follow.
Based on the orientation of the machine or whatever are going on it, then you cosine for j and sine for I. Because
yeah, well, in this case,
angle is placed to determine whether you're using sine or cosine for that on.
yeah, it doesn't matter what you do as long as, so in that case, it will be cosine, it will be sine of 60 and cosine of 30. Really depends on how you do it. So are you trying to find the angle with respect to the positive axis? Is that what it is? This is the negative x-axis. This is going to be.
Well, let's just say we have to 30 degrees right now, you rotate you 90 degrees to the left. Then you use sine to find out, and use cosine to get the same.
Okay, so there are multiple ways of finding the vector. As long as we get the same answers, you're good. So try to do this. Yeah.
This is like a super quick question. Earlier, whenever you showed us the A, B, so B respect to A, that's just because it was like floating. So it didn't really have a direction. Now we have A1 inside, we use whatever the angle is to say which direction it's going.
No, the formula they wrote down there determines the direction. So in the formula, I have B with respect to A. So A is down in the earlier formula. A was actually up, right? A was up and B was down. So here just the A is posted. Just this formula, this is the formula. You draw the arrow from A to B. That's it.
How do you select the from object to the
Oh, so a vector is given by a magnitude and the direction, a unit vector in the direction. So any vector can be written as a magnitude times the unit vector in the direction in which that vector moves. So in this case, the vector omega is pointing out of place. That's omega of place. Similarly, for the vector AB, the length of AB is 1.5, and the unit vector, this vector has unit magnitude. You can take the square of this plus the square of this is equal to 1. Okay, so your question, how do you find the cross product? So some things are very obvious here. It's VBJ, you don't have to do much here. 3i plus 1.5 omega AB. And now I need to do, minus cosine 30 degrees k cross I plus sine 30 degrees k cross j. Okay, what I did was essentially took this k and turn it inside. But I need to carry out this cross product. And I think many people do have a hard time doing the cross product. So the way I like to do it, and see if you think this is simple enough, is I draw a circle, I show an arrow in the counterclockwise direction. I write I, J, K. Okay. Note that I, J, K is the counterclockwise positive, and I write I, J, K. I don't write K of I, K, J or anything different from that. It has to be I, J, K. So K cross I. Okay. K cross I. So as long as you're going from K to I, you're positive. So K cross I is J. So that is J. And K cross J, so if I want to go from K to J, the shortest path is this way, but this is going clockwise. That's counterclockwise. Clockwise. So when you're clockwise, it's negative. So this is negative I. So that's how we do it. But there's another way to do it where you write like a determinant. That's the way probably it is in the prereq the review. You could do it that way. But I think it's just complicated to write that way. Yeah.
You said K cross J because you're going that way.
Yeah. So I always draw this figure. Just remember to draw this. If I want to find K cross I go from K to I. This is the shortest path. I do not go this way. I go to the shortest path. The shortest path is counterclockwise. That's positive J. If I want to find Kj, I take the shortest path. Shortest path is this way, but this direction is clockwise. So I put a negative sign and I put K. So this J is different from K and I, and that I is different from K and J. So the third one, the third vector will show up here, and the sign comes from the way you.
So if you want now to find AK would still be positive and negative, right? A to K. J to K.
So if you want to find J cross K, it is positive I. I cross J is positive K. K cross I is positive J. If you want to find I cross K, it's negative J, because if you go this way. If you go this way, it's negative.
One step before that, with the negative number of times because of,
That is from here. From here, that's because if you resolve the vector along negative x direction, right? Okay, so I'm going to just do this quickly. I'm just going to write the whatever answer I get when I carry out this multiplication. But you should try this to carry out the cross product yourself. It comes out to be something like this: omega AB j minus 0.75 omega AB. Okay, so this comes from this, and this comes from this. Okay, so once you have, what you see is on the left side you have only j, and the right side you have I and j. So what you need to do is, I'm going to write this as 0I plus VBJ equals 3 minus 0.75 omega AB I, and I'm only left with 1.3 omega AB j. So what you do is you equate the I components, right, left hand side is equal to right hand side. So I can find omega AB from that. This is equal to 0, so this is equal to that. And then I can equate the j component on both sides. But I would know omega AB because I solved for it previously. So I can stub it here and find it after. So remember that it's two equations, two unknowns. You can solve for those two unknowns because it's two equations. Two equations and two unknowns. So what I get is VB is minus 5.2 and omega AB is 4. Two unknowns. Okay, so notice I've taken VB positive to be upwards. I got negative sign, which means that the actual direction is downward, and that agrees with our intuition, right? D would move down when A moves to the left. The second way of doing this is to use scalar method, where we write the same equation as above, but in the right direction. So I'm going to write the same equation as I've written earlier, but I'm going to write the x and y component. Actually, I'm going to write it much more compactly. So velocity of B, we know it's in the j direction, so I'm going to write this VB y and put an arrow showing it's upward, equals velocity of A. You can see it's a vector, but I know velocity of A is to the right, so I'll just write it as a scalar, okay? And I know it's in the x direction to the right, plus I need to write omega AB RAB. Again, this is a scalar, but I need to put the right direction on it. So the question is, what's the direction of omega AB RAB? Okay, omega AB is counterclockwise, and the vector from let me just write it as B with respect to A. Okay. Okay, the vector from A to B is this direction. Omega AB is this way. Okay, so if you remember what I told you, in order to find this direction, all you got to do is take this vector from A to B and turn it in the direction of omega AB. So omega AB is turning this vector in the direction counterclockwise. So you will turn it counterclockwise and by 90 degrees. That will give you the direction of VB with respect to A. So this is the direction. So let me put a few things here. Let me draw this as, this is 30 degrees, right? AB. I'm going to draw omega AB here. So as I said, this thing here is going to be taking the vector AB and turning it 90 degrees in the direction of omega AB. So it's going to be 90. So this angle here, what's this angle? It's 60. So this is is at 60 degrees. So it's very important to find the direction, because once I find the direction, now I can write two scalar equations. So along y-axis we have VBY equals, so I'm going to find the y component of this equation. So the y component has only VBY on the left side. On the right side, VA is this way, so that's 0 on the y direction. This vector is pointing at 60 degrees, so I need to resolve it in the x and y. I'm only interested in the y, so it's going to point downwards. So it's omega AB RB with respect to A, sine of 60 degrees, but there's a negative sign. Right, and then along x-axis, say on the left side I only have VB in the y direction, so the x component is 0. So 0 equals VAX plus omega AB RB with respect to A. Well, I'm not sure of the sign. It should be minus, yeah. RB with respect to A. So let's try to see what's the direction in which this arrow points in the x-axis. So we need to resolve it along this x-axis. So it's going to be cosine 60, but the direction is negative of I, so it's going to be negative here, cosine 60 degrees. So again, I would have two equations, two unknowns, because RBA is 1.5. I know that. I know VY, I know VA, this is 3. So the only unknowns are VBY and omega AB. So solve for VBY and omega AB. Okay, so when you do this, you get the same answer. In fact, you get the same equations as previous, because what you've done effectively is just resolve it in the x and y direction. So if you remember when you did statics, this is what you did. Right? Sum of forces is 0. In this case, it's sum of all velocity on the left side is equal to the sum of all velocities in the same direction, right, on the right side. Equal. Yes, absolutely. Feel free to use any of these methods. Sometimes, if I tell you to find one of these, not both of them, it might be easiest to use the scalar method, because here you do not have to take the cross product and so on. If you, for example, if I told you in this problem, only to find omega AB, okay, in order to get omega AB, you need this equation. You know this, you only need one equation to solve omega AB. So why would you spend time doing that method? So if the block C is moving downwards at 4 feet per second given here, determine the angular velocity of the bar AB. So that's an unknown at the instant shown. Okay. So as I said, again, you can do this problem using vectors and scalars. I'm going to use the vector method because for this problem it turns out to be much simpler. So when you're writing the vector equations, the previous one there were only 2 points, A and B. In this case, as you notice, there are 3 points, A, B, and C. Right? You can write the equation for any combinations. You get a B, B, C, A, C. What I recommend is going from A to B, B to C. So it's not very useful to write A and C. So I write the equation for A and B and C, ask myself how many unknowns, how many equations, and go from there. So velocity of B is velocity of A plus omega AB crossed with the vector r b with respect to A. Okay. Do I know anything about velocity of B? Well, I don't know anything about the magnitude or the direction of B. Right? When I say I kind of know it, but I do not quite think it is in the I and J direction. It should be in random fashion. So I'm just going to keep it as it is. Velocity of A. You know anything about velocity of A? What's the point A? It's fixed. It's not. If you're going to move, it's spin. So it's going to be 0. Omega AB is an unknown, okay, and R A with respect to B is well, it's known. So omega AB, the magnitude. What's the direction of omega AB? It's going clockwise, so it's negative k, crossed with the vector from A to B. What's the vector from A to B? So it's this way. A to B. So it's 2 feet in the direction of I. Right? Okay, so VB is, I'm going to write VB as VBX plus VBYJ equals, again, K cross I, J, K. So K cross I is, if you go from K to I, you get J in the counterclockwise direction. So it's going to be J, and it's going to be minus 2 omega AB. Okay, so when I look at this equation, I look at the left hand side, right hand side, I look at the I and J component. I see that there are 3 unknowns. And just 2 equations, right? Because it's an I and J equation. One thing you can note from this is that omega VBX is simply 0. Because you have I component here and there's 0 on the right side. So you immediately see that VBX is 0. So I component gives me VBX equals 0. The J component gives... Okay, so I need to compare the left hand side with the right hand side. Look at the I's and look at the J's. On the left side I have the I, VBX with I, and then I have nothing on the I direction. So it's 0. It's technically plus 0 I.
Okay, you're going to satisfy the equation.
There are 2 equations. There's one equation in I, one equation in J. And the other one gives me VBY equals minus 2 omega AB. So that equation I cannot use to solve for VB by omega AB because that's 2 equations. So one equation, 2 unknowns. So I need to do something else. So I've gone from A to B. Let me go from B to C and see if I can set up more equations and try to solve for. So VC equals VB plus omega BC crossed with the vector from B to C. No, C to B. It's always C to B. This minus the first one minus the second. So, okay. Velocity of C. Do I know anything about velocity of C? I know it's 4 feet downwards, so it's minus 4 along J. Velocity of B is it's VBX plus VBY, right? VBX is 0, so I know that velocity of B is VBY along J. I don't quite know the magnitude of VBY. Plus omega BC. I know nothing about omega BC, so I'm just going to assume it's in the positive direction K, crossed with the vector from C to B, or B to C, this vector. Okay, so that vector from B to C is at 30 degrees with the x-axis, and you can see it's along the positive ij, so it's going to be the magnitude, which is 3 times cosine of 30 degrees plus, cosine 30 along I plus sine 30 degrees along j, because it's going to be in this direction. So minus 4j equals vbyj plus omega bc times 3 cosine 30 degrees k cross I plus sine 30 degrees k cross j. Okay, so I can use the same logic here. K cross I, when I go from k to I, what do I get? I get positive or negative j. When I go from k to I get positive j. That's positive j. And then k to j, so I want to go from k to j, I have to go clockwise, so it's negative I. So minus 4, oh, I'm past the time. Okay, so I'm just going to tell you what I'm going to do if I end up, once I get this. I'm going to simplify this, equate the I and j components. So you see that we have two equations, two unknowns, right? The two unknowns are these. So I have two equations, two unknowns, so I can solve for omega bc and bby. You agree with me? Two equations, one for I, one for j, and two unknowns. So I'll solve for bby and omega bc. I'll take that bby, solve it in that equation there and up there, and get omega ab. That's how I solve it. Okay, so I'll complete this and post it. I'll see you guys on Friday. And your exam is next Friday. It covers homework.